Instrumente. Was wird daraus? Was wird da?
Ah, okay. Hi guys, can you guys on the stream hear me okay? Oopsies. Is my voice coming out? Oops. Oh, thank you guys. Okay. Delay. It was some like delay.
So
Okay. Yeah.
last week you ran it through like your Google Drive.
Mm-hmm.
Is that how you want to do it, or do you want to? Because it looks like you've uploaded your slides this time, which we
Yeah.
want to run.
I'm not sure. So can I go just from my slides?
Yeah,
That
it just
looks
the people
okay.
can see it again as well.
Okay, yeah. All right, thank you guys. Thank you guys for coming to my workshop. Oopsies. So today we're going to I guess I'll just present this way. You guys can go to see the comment as well. So today I'm going to go over stack-based buffer overflow. So this is an introductory level binary exploitation. So um, it'll be I'll try to be slow and make sense to those who have like never touched binary exploitation before. And hopefully, if I know some of you are from computer science 525, right? So hopefully, like what I learned, what I'm going to share is going to also reinforce your concept of buffer overflow. Hopefully. So let's go into attendance. So please fill in the attendance form on your phone, scan the QR code, or just put in the link. Oh, I probably should give you guys the link as well. So okay. So Yasmin and Greg will put the link into the chat, also the workshop material link. So download the workshop material from that link, and then I'll chat a little bit while you guys get ready. I also have to fill in the attendance score, unfortunately. So yeah, how I started binary exploitation was I didn't. So I have been getting into information security in grade 11 ever since Dan put me into the club, and then and then I have always afraid of binary exploitation. Even when Jeremy do those presentations, I didn't understand most of it. And then in 2022 February, so when I was still in high school, by the way, I'm junior exec in first year. So when I like played in team with my teammates in like Pico CTS, I just let my teammate do the binary exploitation, although none of us know it. So like we're trying to learn from the very beginning. And then I was like, this looks too hard. So I'll just let my teammates do it, which they did an excellent job on. So we only had 2 weeks to compete, and they managed to learn binary exploitation, I think, in less than a week. And then they solved all the challenge except for the last like ultimate one, which only has 7 solved across the world, which is too bad. It's not too bad. It's impressive. Okay, it was like, yeah, if you're watching this video, and Kingsley, if you're watching this video, good job. Uh, and sorry for like letting you guys going through all that. So and then in June, that's when I officially becomes the exec. And then now I got to do workshop. By that time, most of the workshop were taken. And then the only 2 left were reverse engineering and binary exploitation. And of course, like Adelara opened up more options for me, like break into the box, which you guys can expect a little bit, and forensics. But like then, like I was like, this time I'm going to put some pressure on myself. I don't want to let the Lara disappoint us, so I decided to do the binary exploitation workshop. And and that's why I start to sneak into Dr. Renzero's lecture. I don't have the prerequisites, so I sneak into it, try to learn some assembly. And here I am, sharing what I learned, also what I'm trying to share with you guys. Also, thanks to Ethan over there, helped me a lot with understanding binary exploitation from very, very low level. All right, I'm talking too much. Hopefully, so the workshop link, the trimmer, like the more like the workshop like material. I have like another link. Thank you. Yasmin will post the workshop material link in the chat as well. And then we'll so these are the tools that you might want to have. Sorry guys, if this is too small for maybe I should just I'll share my screen. Or how do I share my screen? Am I sharing my screen? Or no? No. Okay, let me try this. Sorry guys, running into some technical issue here. Sorry. This is my second workshop, so bear with me. Yeah, here we are. So hopefully this helps you guys see better. So here's the link if you would like to download it. And then here are the tools I've posted. Delara helped me post it on Discord before the workshop. Like if you haven't seen it, basically there's not too much tools that you need. You can download GDB as a substitute, but most of the tools that we have, most of the tools that I use in this workshop will be built into Khaled or Ubuntu, so you guys don't have to worry about it too much. If you like to explore it a bit more, you can probably download GDB, or if you're using another Linux machine. If you would like to try the coding part with me, then I would recommend downloading Pwn tool and Python. Otherwise, we should be okay to start. Finally, sorry for letting you guys wait. Yasmin, could you let me know if there's any question in the chat? If there's any? Yeah, you're good. Okay. So today's outline, we're going to go over some very basic stuff. And then we're going to go from there, going to theoretical stuff about buffer overflow. It's gonna be boring, I know, and it's gonna maybe confusing, but it'll be okay once you try the implementation. I know it's a hard topic to get to, especially when you just start to learn about it. So if you don't get it the first time, it's all right. You can go back and watch the recording and try to understand it, and hope that will help you. So, question: what is a bit? Anyone? Any response from the chat? 1-0, yes. 1-0, 2 states. Okay. How many bits is a byte? 8 bits. And how many bytes does a key character take? Yeah, I hear one from back there. I'm not sure who said it, but yeah. You're all good. And here are hexadecimal characters from 0 all the way to 9, and then A to F, each representing 10 to 15. Just a very quick review, because we're going to get to that once we get to the return address part. And 2 hexadecimal characters represent a byte. Remember that. We'll get to that later when we get to the return address. And summary. Good?
Yeah, we're good.
What is binary exploitation? Exploiting a binary that it is. That's it. So we're trying to do some behavior. We're trying to do something that's not the program intended to have us to do. So buffer overflow attack is a type of binary exploitation in the memory. It's a type of memory corruption exploit. This is probably a bit too technical, but I have to know about this. We're just learning by buffer overflow today, and a buffer is where you store memory temporarily. Memory layout. So when we talk about binary exploitation, especially memory corruption, we have to get the basic out of there first, memory layout. So this is a diagram of RAM that I made for you guys. Appreciate my hard work. So we're going to take a look at this part specifically today, but there are other parts. Also, I would like to introduce you guys into registers. We're not going to look at too much registers today, but we're just going to look at like 2 of them technically, but like I put in 3. So you'll see that like I have put in the next slide. So there's EIP. So by the way, registers are not inside RAM. They are directly integrated into your processor, which is CPU that you know. And these pointers are pointing to your memory locations. Like they store the address of this. Like so, there's instruction pointer in x86 system is 4 byte and this like EIP, and then in x64 system is 8 byte, which is RIP. So all the pointers in 64-bit system are starting with R, and all the pointers in 32-bit system are starting with E. That's something to keep in mind of if you want to do, like if you have more challenges later on. But today we're just gonna focus on x86, which is a 32-bit system. So and then there's a instruction pointer pointing to the text section of the RAM, and then there's base pointer pointing to the stack section. We'll get to that later. Don't worry if you don't understand. I know this is probably too much for the first time. I'm sorry if this is too complicated. I couldn't find a better way to explain this. So here's your stack. For those of you who might not have seen the program before, so this is a C program. In C, we'll start from main and then go from there instruction by instruction. So you can see at first, it's pointing to EIP, which I mean, EIP is pointing to main. So why is switching? So and then so for each function, we push a stack frame onto the stack, and then go from there. So in this program, first we have so normally EIP points to the machine code, but here just for readability, comprehensibility, I'm putting the actual code here, like the C program code. But usually you'll see like assembly. So at the very beginning, when you push the stack onto this stack frame onto the stack, it will allocate a return address and a base pointer. So the ESP and EBP are the pointers pointing to the stack. EBP keeps track of the base pointer, and ESP keeps track of the top of the stack. By the way, when we say top of the stack, it's the lower return address. So if you take a look, so the address, I mean the stack goes from higher address to a lower address, but I'm visualizing it growing up because that seems to make more sense to put like on top. And then we're allocating buffers for local variables. Then so we can see that EIP here is like changing to the next instruction, and then it will go to the next instruction. So after coming here, where do we go next? We're going to function 1. So in this case, because we're calling another function, we're allocating another stack frame. Another stack frame. Here we go. Onto the stack, and you can see that like the instruction pointer went to like the function. Okay. So wait, how does it go back when like it finished executing? Then no worries, because we're pushing the return address to the stack. So that's where, so this return address is where you go after finish executing this function, if that makes sense. Any question from the stream chat? Okay. So if you guys have any question, post in the chat. I'll try to answer you guys as much as I can. And here's a safe base pointer, which points to the previous base point, like previous base, like bottom of the stack. Yes, bottom of the stack. Previous bottom of the stack of the previous stack frame. Sorry, guys. And then we're allocating another buffer for our local variables. Got the parameters from the previous so from here, and then we're returning. Yay! So now because we're returning, the stack pointer will move back, and then now the computer itself will pop the base pointer into our EBP, which is our base pointer. So the saved base pointer here is an address, so it will pop that address into our pointer, and then it will go to the like bottom of the stack of main. And you guys can see that this stuff that we put onto the stack are actually not disappearing. We're just moving the pointer down. So next time when we call another function, we'll move like overwrite all this information. And we go to the, so now it's executing the program. So the return address will be popped onto the into EIP, and then we'll give the control back to our system kernel. And that was chaotic. I know. It's all right. We'll come back to it later on again when we talk about buffer overflow exploit. So buffer overflow happens when the program does not check the boundary between buffer and other parts in the stack, and it allows us or program itself to override the buffer. So these are the vulnerable C functions that are commonly involved in buffer overflow. But guess has been so when you trying to compile the program, so usually the compiler would tell you that do not use gets, it's dangerous, it's obsolete. So most of the time you just have to watch out for these two guys over here. Good. And you're stuck here again. Sorry guys, I have to make you go through this, but we're going to go over this quickly. So same thing happening in the stack, but this time we're taking user input, and that's where it gets dangerous. Because when we user input overrides everything in the stack right past where it is supposed to be, we get segmentation fault. The program crashes. Oopsies. So how can we use this to help us do some funky stuff? Well, Before that, this is just information for you guys if you ever want to do CTF. Usually, like beginner buffer overflow CTF have functions that contain the print function or access to shell. But skipping over that, buffer overflow in action. So this is where the actual exploit happens. So we call the wrong function. So right here, from main to wrong, and then we're allocating buffer. Then it's asking for user input. Now we can overflow the buffer. And guess what? Remember, like when we say, when we talk about EIP, like when it comes to here, the return address is popped into our instruction pointer, right? Remember that? Refresh. So that brings us back to the program execution process. So where we left off and continue executing. What if we change that address to a function that we want to call, like this? Then we'll, after finish executing, it will go to that function that we call instead of going back to where the min was supposed to go. So if we call, like, if we replace to this address with wing's address, then instead of like after getting here, we're going back to min and then return 0. We're going up to the wing function and then print our flag. That's how the exploit work. So of course there's not always a function for you to call, but that's more advanced topic that you probably want to learn in computer science 525, which I know some of you are here are from. All right. So implementing a buffer overflow tag. Wait, what time is it? 16. That's impressive. I used like 1 hour to explain all the stuff during the demo. All right. Any questions from here? Is there any questions from the stream? Okay. So if there's no question, I'm going to get into the hardcore stuff. Finally, you get to exploit the program. So I dissect both like the exploit into 4 steps. First, we find the vulnerable part of the binary, which usually, like in the beginner one, it's super easy, but when you get to the hard one, like into like more complicated CTF challenge, it's gonna be really like trivial to find, because sometimes it's like off by 1, you have to figure out where are they like occurring. But for this workshop, for your benefit, for simplicity, I'm just making it super clear that where the dangerous function is. But if you ever get into CTF challenge, just beware of it. And then secondly, we find the number of offsets. So if we go back, you can see like we want to overwrite all this stuff before we get to the return address. So how many A's or garbage do you want to put before we overwrite the address? That's another part of the exploit. Third is find the address of the program that we like, the function that we would like to return to. And fourth is putting them all together and then get our flag. So first, find the vulnerable part of the binary. In beginner buffer overflow challenge, usually these 3 functions are most dangerous ones that you should be looking out for. So for guess, I think it has been removed from the library after C11. Scanf and string copy are still in use. So the difference between guess and scan string copy is that scanf and string copy do not, like if you put a no character into it, then it will break. So that's one of the difference. But going to the next part. Find the number of offsets. So there are numerous ways to find the offset. You can calculate the offset, which I know some of you in computer science 525 is probably doing that. You can also use cyclic pattern, which I find is pretty useful and helpful for beginners who do not understand stack at all. So you don't need any knowledge on stack to do the stack buffer overflow attack. Sarcastic, is it? So beginner friendly way, we can find a offset generator, and then just I searched this up online. So if you click this link, and then it will take us to a new page. So this is one of the websites I found that you can use to calculate offset. A bit different from what I see before, but looks right. That's all right. And if you wanna do it the scripting way, then you can use Pawn tool, which has a cyclic function that helps you generate cyclic patterns. So I'm going to do a demo here. So if you guys have the workshop material ready, I'm going to show this on example.c. So here's our code. Pretty similar to what we see in the workshop. We are calling min and then von, and then the von function is having a vulnerable function right here, guess buffer. So this one, because it doesn't check user boundary, allows us to overwrite the other stuff in the stack. Oh, by the way, I almost forgot to mention that. So going back, notice how the stack is going from high to low, but like the user input is going from low to high. So that's one of the things that you have to keep in mind. And go back to our demo. So what we want to do here, anyone knows what we want to do right here? Anyone brave enough to say it out? I know you guys probably know it. I still like some answers. Yes.
So we think find publish offset to the return address and then find the return for function one and add this function one and have to put that in the offset of like after 30.
Oh, you're going too far. Yeah, that's not called. So beginner friendly way first. So what we can do is we can generate a buffer overflow pattern. So you can see that I allocated 30 bytes of buffer here, but just to ensure, because sometimes system has padding, so just to ensure I get the correct number of offsets and reasonable length is probably 100. I know it's probably not reasonable, but that's definitely something that can overflow to the return address. Because remember, when we get to the end of the, I switch back to my slides. So when we get back to the previous function, we're returning this return address, like popping this return address into our EIP. So the instruction pointer. So by overflowing that, like by overflowing the stack, when it goes to the return address, instead of like the actual return address to where we left off, we're going to random offsets, and that's how we can calculate using that value to calculate the distance between the top of the stack where we put not the top, but like where we start putting stuffing and just before the return address. That's a word. So let's create a string and then copy that, echo that into our program. So that's our example. And segmentation fault. Okay, now we want to know what's inside instruction pointer. How do we do this? Well, there's a built-in tool in Kali called dmessage. You probably need root privilege to do this because this shows you the buffering of the system. So in my password here, and here is where we are getting segmentation for that. So that's the instruction pointer that that's what the instruction pointer code. So copy that from the terminal. By the way, the copy in Linux machine in Kali is Control-Shift-C, so you don't have to manually type it. And then put it here. I think it says add a 0x to it, telling it is a hexadecimal. And here we got our offset, 42 bytes. So another way we can do this is we can open up our Python 3 program, import Pong tool. So from Pong, import all. Then set our program to the example. And you can see here, there are you can probably see there are some extra information right here, but that's what you don't have to worry about that for now. If you ever wanna get deeper into binary exploitation, there's concepts like pi and pi for ASLR, remember, I think, and Canary, which help guard at the bottom. I had a workshop challenge. I mean, I had a challenge of the week on that. I'm surprised how many people solve my challenge actually. And then we start a process. So from here, we're sending the binary some cyclic pattern. So cyclic 100, that's the number of bytes that you want to put into it. Cyclic, I can't spell it. And then we can go interactive and wait for it to run, and then wait for it to crash. Okay, now it's crashed. What next? One way you can do this is if you open another terminal. I'll try to make that larger. You can still go to sudo dmessage -c just for cleaning it because I don't want so many garbage in my terminal, and then you can see that it's exporting at this place. Another way you can do it, which you probably want to have your core file enabled. Otherwise, it's not generating the core file, but you can use core file. So this is a crash report after a specific program crash, and then your Linux system will generate a kind of report on what's going on over here into a binary and then send it to you. And then using that, we can see it's the same thing. It's the same thing right here. So this one is just integer form of it. And then we can use cyclic find to help us find the offset of our IP. So 42 bytes. Here as well, if you used sudo dmessage. Oh, I cleared it. Never mind. But it was the same address, so you can just use instead of using core file, you can copy this address and then put it into cyclic find, and that helps you find the offset as well. So in your challenge package, I have a small function right here for you guys to try. If you guys wanna give it a try. Oh, by the way, if you are using GDB, I forgot this. If you guys are using GDB, you can also find this, or if you use Metasploit, there's also pattern generator. There's quite a few ways that you can find the offset, but just GDB example, and then I have to run it first. Deleting offset. So if you run it, and then, excuse me. Okay. Okay, so it's loading the function. So if we run it, and then, never mind, it's not running. Not a valid format. However, the previous two methods should be sufficient. For you to do that. Oh, and if you're a pro of a pro, you're really pro, like you're super excellent at binary exploitation, you can also use GDB example, and then you can look at the assembly code. I know this is probably not gonna benefit the beginner. I mean, one function. Yes. So from here, is it's calling get function right here, I believe. Wait. Says, yeah, I think it's calling the get function right here. So in that case, we are reading from EBP minus 0x26, which I need to pull out my calculator. I was pull it out at home, but here, well, my calculator, 0x26, so that's 38 in decimal. And then because I know this is a 32-bit binary, and by 32-bit binary have four like address that's like 4 byte. So right here is EBP, and we know like the return address is below the saved base pointer. So going down like 4 more, that gives us 42 as well. So that's one way you can just calculate it without using cyclic pattern or buffer overflow pattern or anything like that. Cool. So I'm giving you guys 10 minutes, 5 minutes, 5 minutes, I guess, because there's some more stuff to cover. 5 minutes to find the offsets. Oh, by the way, is there any question from the stream? Sorry, guys. No? Okay. So we'll come back at 6:53, and then I'll demo the challenge. So just find the offset of one program, and then remember to put your flag in like wrap your number in UCSec and submit to ORCID org. Don't submit your flag in chat, all right? So All right, I hope you guys have some time to go over the challenge, and I'll do the demo here. Anyone get the flag yet? Looks like nobody's answering. I'm kind of nervous. So I'll do the demo here. So here's our phone function. So first, let's look at the file. Pretty similar to what we saw in the demo as well as in the presentation. Except this time we have 64 bytes allocated for the buffer. And same thing, we go from main to one, and then we get user input. And what we want to do is we want to jump to function one. And so finding the offset, if you use the same tool, the web tool, so we found generating the same string, putting that into the program, and use debugging message, so sudo demessage. We can see the overflow to this stuff. So putting back to the offset generator, the offset calculator, we get 76 bytes of offset. Good. And then with the Python script, first we import column tool, and then we find our program, starting a process, interacting with the program. And then we send the cyclic pattern. Wait for it to crash. So after getting to interactive, press enter, get out of it, we get a end of file error, and then now it crashes. And we can either check it from our terminal, where was the previous one? Check it from here. I think that's the one. So copy down this value. Go back to where we were. Site 0 at that give us 76. Or if you don't want to get off the terminal and you happen to have your core file enabled, you can do it from here. It's core. Sorry guys. And then like find core.eip. I keep spelling this wrong. Sorry guys. So that gives us 76 for the offset as well. So wrapping that into the flag format, which is ucsec curly brackets put that number in, submit it to our orchid, and you'll get the points.
Move the points.
And if you're super techie, you don't want to do the cyclic thing, you can go to the GDB, disassemble the program. You can see it called more, so we disassemble. So disassess stands for disassemble. Well, and then from here you can see that at this place is where we store the where we start writing to the buffer. That's 0x48, which is 72 byte, I believe. So let's check it. So 0x48. So that's decimal 72, and because our safety BP is an address in a 36-bit system that we're looking at, so the address takes 4 byte. So if we add 4 to it, that gives us 76 bytes to overwrite to the return address as well. Sounds good? Good. Good. Okay. So let me see the chat. Is there any question? So anyone has any question here? If not, I'll move on. Okay, I'll move on. So next part. So that's our step 2. We successfully find our offset. Hopefully successfully find our offset. And then next one, we want to find the address that we would like to return to. So there are quite a few ways, like me and Ethan are using different ways, and I know there are probably different ways that exist out there that you can grab out the return address or like the address of the function that we want to return to. So in the example, we can, like in Kali, we have a built-in tool called NM. You guys probably have never heard of it, at least you didn't. Haven't heard of it before. That gives you all the, so you can, these are the ones happening in the background, but something we're looking at is the function we want to return to. So by the way, if you guys don't remember the program, see, so we want to return to function 1, which gives us our flag. So going back there, we can find our function 1 by grabbing it, because I don't want to look through all that. And here's our function address, return address. This looks a bit weird, but okay. And you can also see we have long function here, main function here, and some other backend stuff here. So however, we cannot put our address directly into the place where it should be. Oh, I should also demo the scripting part. Sorry, guys. Oh, and Ethan, our binary expert of the team, loves to use readelf, which is another, I think it's a built-in tool as well. Dash s example. We can grab what function 1. Also gives us the return address of this function. However, what we see here is in a format called Big Indian, but the system doesn't read the address this way. So the system reads address. So this address are hexadecimal, and it reads like system reads the small Indian format, meaning we have to put it into a correct format in order for the system to understand where the program should be heading to. So in Big Indian, which is what we see, usually it's in this order. So 1, 2, 3, 4, 5, 6, 7, 8. But the system reads like what the system want to read is like reads is 7, 8. So from the back going forward, pair by pair. So 7, 8, 5, 6, 3, 4, and 1, 2. And then joining this together, you get the return address that the system wants. Otherwise, the system does not understand you, and then it will just crash because it doesn't understand. All right. So here, anyone wanna guess what's the small Indian format of this one? Say it out loud. Say it out loud.
811000.
Yeah. Right. Correct. So right here, the format should be so the slash x is telling the system that is reading hexadecimal. So it's AD 1100. So that's the address we're looking for in the example. And here's your next challenge. Oh, I forgot to go over the scripting part. Look at me. I'm getting old. Import all. So we get our binary here, similar process. And Pondo is pretty nice because it has function that helps you put it into the small Indian form, which is the P32, it stands for like 32-bit, and then we can get the address by doing elf symbols. So each function has a label which is the name of it. So elf symbols is a list of functions in your program, and then we want to find function 1. Wrap that around, gives you the correct address here in bytes. So B set here stands for bytes. Okay, so now it's your turn. Here. So I'll give you guys 10 minutes for this one, and we'll come back at 7:17. Yes, 7:17. All right. Okay. You can try it. Let's see if there's any question from the chat. Okay, so yeah, sure. So if you have any question for this you on the stream, please put your question in the chat. Oh, can we look back to the function? You mean the code? Sorry, let me show this. So yeah, so the function is example.c. So in example.c, the function we're looking at is function 1. And then what we want to do to find the address of function 1 is by using tools that we just introduced. Oh,
You're not sure.
oh, sorry. I'm not sharing my screen. Sorry. I'm not sure how though.
I'll do that.
Okay, thank you. So Yeah, so that's our function here. So void function 1, printf here's your flag. So that was in the example. This answers your question. Okay. Oh, I see. I can. Yeah, so we're trying to find the function in vol right here, just for you guys to know. Sorry for, I should have this up there. I'm muted. So anyone get the flag yet? Everything okay here? No response. Oh no. Okay, anyone needs more time? I'll give you guys 10 more minutes if you guys are struggling. Might get some response. Oh no. Rip. Okay, I'll give you guys 10 more minutes and then we'll head back. 8 more minutes. So we'll come back. Well, actually, like we'll come back at 7:25, I guess. All right. Just a few more minutes for you guys if you guys want to try it on your own, and then we'll walk through how we get to the address. Everyone can hear me okay? Yes, okay. So right now I'm going to go over the everyone look here. So I'm going over the challenge right now. So how do we find the return address? So let me do the demo here really quick. So here we have our vom function. Vom program right here. Similar to your example, yeah, we're still using the same vom program. We're still using the same program. Actually, this is the only program we are looking at today for your challenge. So we find the return address. Remember, there is a built-in tool called nm, and then m1 gives us the address for function 1 here. I'll put it in the little Indian format. Is x86 84 0408. So that's the address you're looking for. That's a flag you're looking for. Remember to wrap it around. We're waiting for the flag. Here you go. So basically we split them into pairs and then from back to front we put them link them with \x, which gives us the return address.
So we submit it using little endian with the slashes and the X's?
Yes, so right here. Submit your flag like this, but replace whatever inside with the return address that we just found. And if you want to do it in a techie way, so we can import home tool and then link to the program. So what we can do here is use our p32 function, which puts it into the little Indian format, and then alf.symbols finds the address of function 1, and here we go. And the flag will just be cseg, the thing, including the first backslash. So this is your flag. You can, yeah?
So if we have an offset of 76 and then we add that, will we be able to get to function 1?
Yes, that's our next step. I did.
Doing something wrong.
It should be working.
Yeah, nothing something wrong. I don't know what. It's time.
Sorry. I might mess this up, so it might not be your fault. Okay, any question from the chat? Any question from the stream? All good? If you need me to go over it again, I can do it again. If that's too fast for you. All good? Good. Okay. So I'm moving on. If you have any questions, put in the chat. I'll come back and check later on. And then our next step is types of payload into the program. So now we got everything we need. So going back to the previous slide, is a diagram here. We got the number of offsets. We know how many bytes to overflow, and then we know our address, so we can put it all together to create our payload. So payload is the thing that you put into the program, which completes your exploit. So here. So knowing that at the beginning, remember each ASCII character takes 1 byte. So we can just use a random ASCII character, or if you're really good, you can use hex. I don't recommend doing it here. And to overflow the previous part and get you the return address. So let me do a demo here. It's for pawn tools. Beginner friendly way. So knowing that our offset is 76, we can print out A for 76 times. You can use the online repeater to do this as well. Yeah.
Let's use Python 3D.
You can, or you can use so if we go to a online repeater, I'm not sure if we have that tool, but
No, I know there's like does in Python 3D.
Oh, we'll just use 3.
yeah, use 3.
Instead, you're correct. 4. He's talking about like static output genetics that happens with Python 3. In this case, I think we're using numbers, so it's all right.
Yeah. So, or you can, for a beginner, you can, oh, I forgot to put a character there. Okay. So we can repeat it 76 times like this. And then just copy that for all those for YouTube binary, we can copy that, and also the not one example. Oh, that was one. Oopsies. What's our offset, for example, again? That was, I don't remember. Let's go check. So I'm just going fast forward there. I forgot the offset for example. That's why you should have a pen or paper to keep track of what you're doing. Process. Sorry, guys, for taking your time. Cyclic. Okay. Oh, that was 46 bytes. So what we can do is, for those you who are new to binary, we can, and then also have our return address here ready. Putting them together, we get a payload of, it can be anything. I'm just using A here as a like placeholder. So we can actually we need a -e here because otherwise it will not interpret the return address of like as it should be. So just tell the echo to interpret this as x 0x 0. And if we pipe that into examples, that should, oopsies. Okay, let's see what's going wrong right here.
So 76.
76. Do I have 768? Just to check. There's 76 A's. And X AD1100. Okay, let me try it the scripting way first to see what might be wrong right here. So for scripting, go sample. Oh, 76 days. That's why. Sorry. Thank you for. Look at me. Okay. The offset was 42. Yeah. Thank you. uh, okay. I'm still stuck. Okay, so I was mistaking this number as the one in like, but we're doing example here, so it's 42 A's. Repeat the text, copy it over. This time, that it should be working. Hopefully, hopefully. I call the she AD11. AD10. Then type that into example. What else is going wrong here? See, that is the right address. So here I'm just sending 42 A's with the address of samples. Let's look at what's going on there. So set fault at 11AD. Wait, that is the address. Okay, so this is what happens when you try to do binary exploitation, because there's always some errors that they're not. Oh, RIP. I forgot to compile. Okay. So I guess I accidentally compiled this into a 64-bit binary for some reason. That's why I feel like it's not right from the beginning. Let me recompile this. So sorry for you guys who are trying this. This is probably not working. Let's check that. Make sure we're. Check. I think. Dash the file. Dash file. Dash file. Then Christmas rate. Oh. Slash example. That's 32 bits. Let's see the address first. Just to ensure. That is the right mistake that we found. Yeah, that was the right mistake that we found. So I compiled into a 64-bit binary, which in this case, the address is a bit different, and how we exploit it will be different as well. But since I just want to focus on 32-bit system right here, so we're doing this 32-bit. So sorry for you guys who are trying to do it hands-on, because it might be impossible using the way I taught you to do the exploit, but very we're back onto the right track. So it's the same method. We overflow. This should still be like 42 bytes. If we're not sure, we can still check. Copy the string here. Echo it into the program. Look at our buffering. It's happening at this place. Put it into our offset checker. 42 bytes. Yeah. So the number of offsets is not changing. So, but something changed was because this is a 32-bit binary here. Actually, it's not. Wait, what happened before? I'm not sure because it was 4 bytes. Anyways, the correct one should be this one. So the address will be 76910408. But for the flag, it was the previous one, so you guys can submit that one, and we're going to do exploit on this one. Same deal. Sorry guys for taking up your time. So to do the exploit, we pad it with 42 ace or whatever character, or you can do hexadecimal. But if you're doing hexadecimal, remember like 2 hexadecimal character is 1 byte. Is that right? That sounds right. So x 76910408, and here's your flag. Oh, that was an accident. And then live demo. Really live. I probably should practice a bit more, check it before I come to the workshop, but here we go. So using Python script, we can do it this way. So input our binary here, start a process. Then because we already know our offset, we're going to jump over just for the sake of time. Sorry for keeping you guys here for so long. We'll complete the challenge and then you guys can go, but like after this one, like not after this one, we'll have one more challenge, but after that one you guys can go. So that's 42, and then that's our offset. So we are heading it with 42 ace, and then we link our address in Little Indian format, and then so that's our payload right here, function 1. Both as okay. So now we send this payload to our binary and open an interactive shell. Here's your flag. Good? Sounds good. Okay. Sorry guys. That was a really lifetime demo with a lot of accident. Hopefully you guys could understand a little bit. Any questions? Oh, I think the address might be different in different computers. Yeah, it might be. But yeah, sometimes it is. Is it?
These files, they're statically compiled or anything.
Yeah, they're done in a way such that ASLR, which is a special thing that prevents binary exploitation, is disabled. And because of that, all the addresses baked right into the binary. So in this case,
I think I didn't compile this like I compiled this dynamically. Oopsies, sorry. But like for the workshop one, I think it might, yeah, the workshop one was statical, I think.
I saw it. It's not there. Well, there's no ASMR to like that.
Okay, okay. Yeah, so if you're depending on how you compile the program, so if you compile it dynamically, so like when I compile it, I use GCC. So if you look there, so I used this one. So I forgot to have the dash dash static. There, if it's statically compiled, then the address should be the same. Otherwise, it might be different. Sorry about that, but that's not your. Oh yeah, the flag was not there. Where am I? Wait, did I do the demo wrong? Oh no, so for the previous address one, it should be. I don't even remember what I gave Dora. Although, so for the previous one, the phone function, this one. Did I do this one? I think I did. Okay, I'm not doing it wrong. Yeah, so if we're compile it dynamically, then there's a great chance that if like your ASLR, which is a way that system protects itself from binary exploitation, so it randomize your address. In that case, your address might be different, but if it's like statically, then it should be good. Okay, sorry. And I need more questions in the chat. Sorry for those confusions. Okay, sounds like no more questions. Okay, I'll go to the very last step here. So your turn. Put them together, do your exploit. So I have gave you a static binary which does not have a flag in it. And Ethan, have you? Yeah. So let's put this up. So sorry, I forgot to tell Ethan and Laura to like host a challenge previously, but
Yeah.
and sorry, let me get the yeah. So you can start exploiting on the local binary first, and then doing the same thing for the remote one will work. So just a second, we'll get the remote host and the port up, and then you guys can put your payload. Yes.
I'm talking about volume.
Yeah, vol. Yeah, still vol. Still the same binary file. Vol. So once we get the remote address and the port, you guys can do the same. Put in the same payload. But I see, like I can put it on the slide, so you can not catch you. Might have to. Oh, thank you, Ethan. So here's the IP address and here's the port. So go for it. I'll give you guys 20 minutes for this. And that should conclude the challenge. Actually, because we're running out of time, I think I'm going to only give you 10 minutes for this one. Yeah. Sorry for taking too long. My apologies. So this up there. So yeah, almost the end. So you guys can try this one, and then I'll do the demo. Oh, and I'll put this in the chat as well. Sorry, guys. Oh, it's already in the track, so good. Oh no. How do I delete this comment? So that's one. Thank you for calling. Sorry for taking guys so long. My apologies.
Have we succeeded that we're getting response band? Is that the answer? We have enough views, but we're worth spending it. I guess so. Yeah. I just tried to. I don't know. I can't. Yes. So that one was like. But then so I am yeah. I thought that was a time. I can't see anything but that. That's really good. No, that's okay. Oh, good job. Well, this is how. Oh, no, I don't pay attention. 31. Because I have been destroying everyone in this. What's the topic? It's on sorting sun-depth trees, sorting height balance of trees. So you started from like lowest on the left. Yeah, exactly. So on that class on the right, and all these are the same. Is that like a black tree? Basically, but it's using the color for each individual and the actual. Wow. It's very as many as one. The tree is one that there's a tree means there's only one half. A tree means there's only one half. The next class was like.
So all that stuff is inserting it.
So it's
Inserting
easy.
it. And how it's you would learn more.
Yeah. Oh, okay.
I really know it. After that, and also keep it ordered and keep.
I also took it to see. I had the same time. So I.
Which ones would have stickers? Yes.
How did you wow? We had to go out and not
Yes, you work in flow.
you actually get updated. It's like, you got the difference. Christina, just so you know, your shared screen has gone dead because of that.
Oh, okay.
Well, it's not like you like 1,000 questions, I'm like.
Yeah, we'll get a zero on question. Maybe you can go whenever you.
You can create it as an overseas.
There's lots of things on.
Is the session already? Is the session already?
There's so much.
Which one? I don't know.
Yeah, you're like, which one?
It's the common. Oh, you need to block. Where here? There's no way. Nothing but the. And I think you have the other air. Yeah. You just there's some cover there. It's not from the perspective of the for the last sort of yeah, and not to my but we know I really.
Yeah, I should do the demo here. Sorry guys, it's taking too long. I'll try to go over this fast. Sorry if you still want to try it, I can still try it. But I'll go over how to do this challenge here. Bear with me. What? Oh, so I'll do this. Yeah. So sorry, it's taking too long. My bad. I didn't do the time like there's answers, and sorry for keep you guys here. I'll do the demo really quick. So you guys can go home earlier. And for those of you on stream, if you want to try it on your own, you still can. But I'll go over it here. So we have our phone.c. So same files, the same goal. We want to get to function one. So previously we have find the offsets and the address, which forgot the address here. So the offset was 76 and the address is right here. So now we want to pad the front with 76/8. So don't need this anymore. So 76. So beginner friendly way, 76/8. And the address we want. So echo machine /x 86 84 04 08. And then we can try it out on our like local binary here, and then we get a indication that we're printing the flag. So now we can netcat, so connecting to our what's the IP address. So now we can netcat to that and then pipe that payload to our program hosted on the remote server. And that gives us flag here. Sorry for doing everything everything so slow and also rough. But if you guys want to check the scripting part out, I'm typing it here. If you guys feel this is too fast, you can go home and check the recording and be safe if you want to go home. It's pretty late. And so the address, symbols, function 1. Interactive. And oh, forgot to connect to the remote host. So our remote host will be from scripting is remote, our IP address, which is, I don't remember, but it's right here. So IP address and the phone number. I think that's how you do it. Maybe not. Okay. So now we are connected to the remote host, and we can send our payload again to our remote host. Did I have payload there? Oh, I just had all this stuff here. So we got send line. Interact. And here's your flag. Okay, thank you guys for staying. This is a long presentation. I know, like, you get tired, I get tired, I got nervous, I'm really panicking, like, when the instant happened. Good job, you're playing, like, you implemented basic buffer flow attack. Some additional notes, difference between x86 and x86, so 32-bit versus 64-bit system. Difference in the address, and also some other exploit that and topics I can look into. Sorry, I don't have time to go over it here. And here's some reference. Thank you guys for coming. Thank you all for staying. Oh, any last minute questions on the stream? No. Okay, you guys are free to go. Thank you.